Hey, what's going on? I am starting kind of a new series here where I'm just teaching a few things, kind of like Khan Academy, kind of not. I don't know. I feel like Khan Academy is way too generalized. I'm just gonna try and solve problems of any topic. I feel like I don't really have like a set agenda here, but for this first one, we're gonna go into what is called the new engineering. Kind of like a method of problem solving I learned from Eugene Auditori, a retired engineer living down in Florida. You can find him on his website by the same name. So this will kind of be part one of the series. Uh, Essentially, the whole point of this is normal engineering uses way too many variables, and you can solve it in a different way with less variables. It makes easy problems easy and harder problems also easy. Yeah. Just any highly nonlinear problem will be substantially easier using the new engineering. If it's already linear, it's like whatever, but any nonlinear problem, you're going to save a hell of a lot of time. So, anyway, we're going to set this up left side, kind of lay out one problem in the old way, right side laid out in the new way. What we're putting here is like a really entry-level thermal type problem. Don't even pay attention to the numbers. I'm not even trying to solve these. I'm just trying to make a point here about which way is faster and easier, which way has more variables, kind of general overview. So don't dig into the weeds on it yet. Delta T total equals 120. So your temperature over the system, well, just the generic 120 there. The change in temperature 1, that's going to be equal to 1.99 Q point to the raised to the 0.75 power. So Q is just your heat flux. Delta T of the wall, it doesn't have to be a wall, it can be X, call it whatever you want. 0.5 Q and delta T2, so pretend that's whatever's on the other side of the hypothetical wall, is 1.16 Q to the power of 0.667. Triple Q, 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 Q. Q ball from the cuts. H1 on the other side. H is just your thermal coefficient. If you got, I don't know, if you haven't taken thermal, this is probably going to be meaningless to you. It might be meaningless to everyone, but it's helpful for me to learn, so I don't really care if anyone watches this. But heat transfer coefficient is H1. I might have called it something else a second ago, but it's your heat transfer coefficient is H. So H1 is equal to 0.40 delta T1 to the power of 0.33, and T, which is the thickness of the wall, and K, which is your thermal conductivity, is just going to be equal to 0.5, and H2, 0.8 delta T2 raised to the 0.5. So U, which is like your overall total heat transfer coefficient, just think of it as like all the H's kind of together, is 1 divided by 1 over H1 plus T over K plus 1 over H2. Again, we're just doing this to look at variables. Don't get caught up in trying to actually solve these problems because I'm not going to do that. I don't really want to do math right now. U is equal to 1 over 1. We're just plugging in the variables here. 0.4 delta T 1.33. See, just took that H1, literally just plugged it in. Plus T over K, we know that's 0.5. Again, I am just going to plug it in. Super easy. Oh, and I messed up the super easy thing. I wrote the wrong number. That should be 0.5, but you get what I'm trying to do. You get it. And the final one, 1 over H2. H2 is just 0.80 delta T2 to the 0.5. I guess I'm trying to add in some blue lines here to make it a little more clear, but I'm probably actually making it less clear. But it's fine. We good. So you look at that problem. You've got all these variables in it. It's got a bunch of fractions. I don't know. To me, it looks really hard to figure out. I wouldn't want to do it, quite honestly. It's just too hard. You know, you've got u when and u is a variable in its own right. U is just representative of Q over delta T total. That's a variable. You've got delta T1, delta T2. It's just a pain. The new way, you're getting delta T total equals delta T1 plus delta T of the wall plus delta T2. So we already know those. 120 equals 1.99 Q plus, oh, no, I didn't like that. The 0.75 was like unreasonably high, so I had to bring it down. Probably wasted time. Plus the wall, that's same thing, 0.5 Q plus 1.16 Q, 0.667. Take a look. Look at what's important here. There's one variable, a Q. Q, Q, Q. Q is equal to 141. Easy problem to solve. Put those numbers in Excel. Freaking that'll solve itself on its own. Like, that's fine. That is not a hard problem. So, in conclusion, less variables are better. Obviously, the right side is the easier problem to do, and maybe they both look hard to you. Maybe they both look easy to you. Believe me, if you get into highly nonlinear thermal problems, the right side is going to be much, much easier. But again, don't get too deep in the weeds here. It was literally just showing you which side had more variables. Left side has 3, the right side has 1. So a lot of people would ask me right about now, how are these two equations even the same? Kind of goes over my head when I first started. Like, I don't understand how like the left side is even equal to the right side. Other questions like why are we even doing the harder way at all? Why is that what they teach in college? Well, because the college professors are really dumb, a lot of them, and they just teach what's in the textbook, which is pretty much what's been taught since like Joseph Fourier just discovered this stuff. And it made sense back then, but it really doesn't make sense anymore. So let's kind of get into that first question. How are those two equations even related? So your total U is equal to 1. Let me write this out here. 1 over H1 plus thickness over thermal conductivity plus 1 over H2. And that is just a fancy way of saying U is equal to Q divided by delta T total. Q is just the heat flux, so all we're looking at is the heat flux over the entire range of temperature, and that is your total heat transfer coefficient, U. H is Q divided by delta T. Whoops. I don't know why I wrote total there. I'm just gonna cross it out. It should be delta T of like the local area that applies to that age. Anywho, Fourier, Joseph Fourier made a law. Joseph Fourier is a freaking baller, genius. And his law was Q, the heat flux, equals K times delta T of the area divided by thickness. This law will be important later, so will Fourier himself. So all these variables are going to get us kind of going on our new equation, which we're just rewriting U here. Nothing new, just plugging in these variables into the original U equation. We know what U equals, Q divided by delta T total. Plug that in. We know what H1 equals, so this is going to be 1 divided by Q divided by delta T1 plus T over K plus 1 divided by Q divided by delta T2. All we're doing is substituting for H2. And all of this is under 1. It's kind of cropped off at the top of the screen, but it is under 1. And we're going to start rearranging this equation. Get some arrows really quick. So to get everything out from under that 1, we're going to divide the left side by 1 and multiply the right side by it. So now you can see it. The whole right side is no longer underneath that 1, but the whole left side is now underneath the 1 we're dividing. So 1 divided by q divided by delta t total is equal to 1 divided by q divided by delta t1 plus tk plus 1 divided by q divided by delta t2. You can read. I don't need to speak this out, but why not? All right. Let's do some math here. We're going to multiply everything by q now. What we're doing is rearranging variables, nothing too complex. Multiply both sides of this equation by q, by your heat flux, and then we're just going to start canceling bad boys out. It's nothing but just rearranging numbers and letters. Actually, like, the only number we're even touching is a 1, so it's kind of like just playing with the alphabet here. So start canceling out your q's. Give it a second, I gotta write this out. Yeah, that looks bad. Yeah, sorry, I'm crowded in. They got me crowded up. All right. Cancel a Q. No, I'll do a red marker. Hold up. All right, Q cancels out. Q, don't need it. That one, we don't have a Q to cancel in the middle, but Q on the end, get that out of here, boy. We don't need that. We don't need your Q out here. So let me change the color here really quick. So what does that give us? When everything is canceled out, that first term then just becomes delta T of the total system, and the next term just becomes delta T1. The next term just becomes Q times thickness divided by K. Sorry, just noticed Alright, that looks a little better. And no, 1 second. I don't know, I'm OCD, I need a second. Alright, that looks better. That makes more sense. Alright, put some drop down arrows to kind of explain that better. That becomes that becomes that. The middle does not really change at all. We're just keeping that the way it is. And then the far right side is going to become delta T2. Easy peasy lemon squeezy, boys and girls, and people that just fit into anywhere on the spectrum. It does not matter. Anyone can enjoy thermal math. All right. So we got this equation. Delta T total equals delta T1 plus Q times T divided by K plus delta T2. Wham, bam, pretty cool. So let's take Joseph Fourier's law again. It's going to come into play now. Q is just times T divided by K is going to be equal to delta T. All I did was just rearrange that equation. Super easy. If you don't know how to do that, it's the wrong video for you. Or because Q divided by delta T, same thing, just rearranging the equation here, manipulating it. I'm going to call it Tx now because it could stand in for anything. It doesn't matter what it is equal to Kt, K over T. Therefore, Q times T divided by K has to be equal to delta T X. And this is what I was treating as delta T wall up above. Like, it can be whatever you're talking about. That is equal to that right there. Q times T divided by K, that's your delta Tx, delta T wall, whatever you want to think about it as. So what does that mean? Let's check it out. Let's make some nice, pretty arrows to make this very obvious for everyone. All right. So all of this math and rearranging has just showed us delta T total for the system is equal to delta t 1 plus delta t x, wall, whatever you want to call it, plus delta t 2. And we got this equation from that weird u equals 1 divided by 1 over h plus t over k plus 1 over h divided by 2. What we did is, sorry, this does not move the way I thought it would. What we did was literally just eliminated h as a variable. All h did was slow us down and make the equation longer and more difficult and more annoying. So it's like, homies, why are we using h at all? Why? Like, I just proved with the math, you don't need that h in there. You can solve the same problem just with the t's. And this is what I kind of was doing in college, and the professors were just like, no, you have to use h. And I'm like, why? Just remove h and everything's easy. No, you can't remove h. It's like, I can though. I'm doing it. I'm doing it on all these problems and I'm getting them done quicker and easier. No, that doesn't make sense. Well, look at my math and tell me where I'm wrong. They would look, well, you're not wrong, but it's not the preferred method. It's like, what? Why, how is it not preferred when I'm doing it easier and quicker than everyone else in this class? Whatever. So anyway, remove h, it all gets easy. Delta t is equal to a function of q. That is what we just proved here. That's what all of this is saying. Delta T is just a function of heat flux. One sec, get my colors in order. So, we know heat flux is equal to H times delta T. E is equal to IR. Now we're getting into some other engineering right here. Stress is equal to the modulus of elasticity times strain. But what if I told you all this stuff is just wrong? Because H is just a representation of Q divided by delta T times delta T again. R, it's just a representation of E over I. Modulus, literally just sigma over strain. Like, why are we introducing these random variables? And I get why. I'll get into that in another video. I mean, like, we would assume they're helpful, but they're not. Like, you're just adding another letter to figure out when you could just use the original letters. Like, I don't know. It makes no sense to me why people are using those letters. Not the letter itself, but the variable. You get what I'm saying? Why add more complexity with more variables? So H, R, oops, circled the wrong E. Shit. One sec, let me get rid of that. There we go. Alright, so just your elastic modulus, getting rid of that. No reason for it. Alright, I hope that gave you a little bit to mull over. In the next one, I'll kind of get more into the theory of why did Fourier like even do it this way to begin with? Why have we not changed it in like a few hundred years? Like, I don't know. There's so many problems with engineering and the way people just don't question anything at all.
And I know people are going to come in here and, ooh, that was a boost in mic quality. Wow, I should re record this whole thing. Whatever. They're going to come in here, the haters are going to say, Jay, we already know that H and R and E, they're all representative of two other variables, and that's fine. We created those third variables just for the ease and simplicity, and it's been working this long. We're not going to change it. It works, it's good, and to them I say, you're wrong, you're dumb. And we'll get more into that. We'll get more into the history of who discovered these things, who first started doing it, and solve some more problems, especially some highly nonlinear problems with both methods. And it'll just be plain as day why you would want to get rid of those um, made up human constants like h. But for another day, probably a long while from now. This video went pretty long. I don't intend for that to happen. I'm aiming more for like 5 minutes. This is just like a topic that I've been wanting to get into for a while. I don't know. I'll probably just solve like one little problem, post it up. Problems I had to do that I remember trying to get help on and not being able to solve. Maybe dabble into a little bit of personal finance, stock trading. I don't know. What do people want to know about? I don't know. I'll pick a couple friends' brains. Maybe get a friend on here. Talk about some other stuff. But I don't know. Just trying to get some knowledge out there. Give me feedback if you got it. I'm sure this math was riddled with errors. And if nobody watches it and it's just me watching in the future, keep on trucking, Jay. You got this, buddy. Signing off. Thank you. Come again.